First of all, when it says to draw angle BCW, an angle is two rays that share an endpoint. That endpoint becomes the vertex. So in this case, CW and CB are going to be the rays that we're going to be creating here that will create that angle. So looking at C, that's the vertex. CB starts at C and goes on forever in the direction of B. So you put a little arrowhead on it here to show that it goes on forever. And CW, you start at the end point. Draw a ray that goes through the point that identifies the direction. And now you've got an angle. Okay. The angle is BCW. If you're talking about a ray, you're talking about a line over it with an arrow, with one arrowhead pointing to the right. Okay. This is how you indicate what rays are. And the first letter is the end point, and the second letter is the direction that the ray is going. This asks, are GJ and GH the same ray? So G is the end point, and if I go in the direction of H, that's my ray right there. And if I go in the direction of J, because they're collinear points, I'm going the same direction. So GJ and GH are the same rays. Okay? Because if you start here and go in this direction, whether you call the direction of H or you call the direction of J, it's the same thing. In contrast, HJ and JH, where are they? HJ would start here and go this way. JH would start here and go this way. They are not the same rays. Number 4 is asking you to do the same thing that the question did for you in number 2. Right? Number 2 asks you GJ and GH, are they the same rays? Now they're asking you to go ahead and make two names for the same ray. The ray they're talking about is going J through G and heading in this direction. Well, on the way to G, you've got to pass H. And again, they are collinear. So JH is the same ray as JG. And in order to make it a ray, you put a little line over the top with a single arrowhead on it. Yeah. For number 4, could it also be what? K actually identifies the line, not the ray. So K identifies the whole line going in both directions. By the way, notice HJ goes this way, JH goes this way. Those are two rays that go opposite directions. They form a line, but they are not opposite rays. In order to be an opposite ray, you've got two things you need. They've got to share an end point. Two rays have to share an end point, and then the directions that they go have to make a straight line, have to make a line. That's what makes opposite rays. Now here, this asks, what is the intersection of JG and plane A? Plane A are all of the points infinitely spreading in both in this direction and that direction in two dimensions. And line JG goes infinitely in this direction and all the time is lying on plane A. There is some confusion among you about what an intersection is. An intersection is not the place where two lines cross. An intersection is all of the points that two shapes have in common. And if you look at this, every single point that's on this line is also on plane A. The line itself is lying on that plane. So every point on the line is on that plane, and that means the intersection of the two, line JG and plane A, is the line itself, because that's the set of all the points that they have in common. Anything that's on JG is also on plane A.
I don't really understand.
Let me go over it again. The intersection is the set of all points that two shapes have in common. This point G, is it on plane A? Okay. Is it on line JG? Great. Then it's part of the intersection. Is point H on line JG? Is it also on plane A? Then it's part of the intersection. Is point J on plane A? Is it also on line JG? It is. And so that means that all three of these points are part of the intersection, and all of the points in between are actually both on the line and on the plane. And that means that the two shapes share all of the points that are on the line. And that's what makes it the intersection. Yes, ma'am.
Why isn't it DHT?
Because DHT is a line that has absolutely nothing to do with line JG.
But it's going through it. Right? It's like, what's...
Okay, here's the problem that we're facing. The problem that we're facing as a class is that I'm telling you what words mean, and you're saying, no, I already know what the word means. It means something else. That's not going to get you where you want to go. The definitions are important. If you think you know what the word intersection means, you may not be right. An intersection is not where two lines cross. That may be an intersection. The intersection of this line and this line is this point. But that wasn't the question. The question was, what is the intersection of this line and this plane? Well, they don't cross at a point. This line actually lies right on the plane, and every point that's on this line is also on this plane. What's that have to do with intersections? Well, the definition of an intersection is all the points that two shapes share. That's what it means. So now if you use that as the definition and you're looking at this situation and you're saying, well, what points are on the line and on the plane? Because that's what sharing means. They actually belong to the plane and they also belong to the line. If you use this as your definition, every point on this line is also on this plane, and that makes every point on this line part of the intersection of this line and this plane. A pair of opposite rays. Use proper notation. I actually see two pairs of opposite rays here. Anybody want to identify two of them? Yeah. Right, those are opposite rays. They share an endpoint, HJ and HG. Right? You got to put an arrow on the line over the top. And then, yes.
HD and HT.
You got it. Okay.
Good job, Jordan.
HD and HT. Those are also opposite rays. But they're the only ones there. It's not just that they go in opposite directions. If I'm trying to define opposite rays, I can't just say, well, they're rays that go in opposite directions, because I don't know what opposite means. What does it mean? It means they share an endpoint and they form a line. So now, give another name for line K. There are several names we could do for that. Keep in mind that when you do a line, it has only two letters. Not three, but two. Line GJ would be one, right? You could take the other letters, line JG, line JH, line HJ, line GH. Basically, all you need to do is pick 2 points that are on the line, and since it goes in both directions infinitely, it doesn't matter which one you put first. Give another name for plane A. Well, you can name a plane in 2 different ways. Go ahead.
JHJ.
JH.
I'm sorry, GHJ.
GHJ. Well, the problem with that is if you give 3 points that are lying in the same line, it could actually mean an infinite number of different planes. You have to pick 3 points that are not collinear. Okay? Yeah.
DSB,
DSB.
I think.
Okay. Now, here's the problem with that. This line right here is the one that's going through the plane and intersects it only at point H and then goes down this way and then goes above it here. The point D is not actually on the plane, right? There's this one plane that's drawn here, and that's plane A. So that's like this piece of paper here. So every point you see right now is on that plane. Now, if I do this, right, you're still looking at a flat screen, right? So theoretically, at least, the whole reflection there is on the same plane. It's all on the screen. But your eyes actually pick up, and your brain actually picks up a couple of signals here. One, there's a shadow. And the other is that the line sort of disappears when it hits the hole, right? So you know that that pencil is not lying flat on that piece of paper, right?
Yeah.
Okay. In the same way, that's what this is. Okay. H is where this line goes through the plane. The fact that this is a dotted line sort of represents the fact that you can't see it.
So it's no on it, right?
Right. This line, except for point H, the points on this line are not on plane A.
So D is?
D is not either. Right. Okay. D, again, in this situation, D would be a point somewhere close to the point of the pencil. Right? It's not laying on the plane. It's hard to tell when you're looking at a flat surface. When I first introduced this, that was the day that I drew this, and everybody agreed that it was, once I started putting whiskers on it and ears, everybody agreed that was a cat. Oops, sorry. Right? Right here. Remember that? And basically what I said is that doesn't look anything like a cat, but you've all sort of absorbed the idea that that's what represents it. Well, this is what represents a line that crosses through the plane but isn't on the plane. Okay? This is what represents this situation here. Okay?
So H would be like a hole?
Well, it's the point through which they both go. So notice if there's a line through here, there's no hole. I filled the hole. And the point H lies on the plane and on the line. That would be the intersection of the line and the plane.
Okay.
Okay? What if I pick 3 points that are not on the plane? Any 3 points. If I pick any 3 points at all, anywhere, if I pick any 3 points, there is one plane that goes through them, like the legs of your desk. If I pick any 3 points, I can put a plane through them. If I introduce a 4th point, I may not be able to. But any 3 points can be contained in a single plane. That's why you only need 3 points to identify a plane. So now we're looking for ray FE and ray LP. Okay, so where are they? Ray FE over here and ray LP over here. We're supposed to mark them as parallel. The way you do that is you put little arrowheads on them like this. An extra arrowhead here, an extra arrowhead here, showing that they go in those directions. But this little extra one that's in the middle, not just on the end, shows that these two things are parallel. Yeah?
What if someone you put two arrowheads?
Well, if I had another pair of lines over here that were also parallel, I would want to distinguish them.
Oh, so it's just in case there's like more than one. Oh, okay.
And some publishers will put two on anyway, just to make sure you don't miss them. That's fine too. But if there are two on this and only one on this, it means these two are parallel. This one's parallel to something else. Okay? And the same thing is true with, and let's just jump down to the bottom, 14. Notice, by the way, that DH and HJ are segments because they don't have arrowheads on their hats, right? They're just little line segments like that. They start at H and go to J, and they start at D and go to H here. If I want to show that they're congruent, which means they have the same length, put a little mark on it like this. Okay. Notice that that's different from the arrowheads. The arrowheads don't mean congruent, and these don't mean parallel. They are two separate things. And just to expand on your question, if I had two other segments that were congruent somewhere else, I would put two little marks. Okay? So that's 14. We've done 11. Draw ray CB on the diagram above. Well, the fact is, we already did that. We did that when we created the angle. Creating the angle required us to make this ray, so that's done. And then mark line WS on the diagram above. Here's W, here's S. In order to show that there is a line, you just need to draw a line like that, line segment, and put arrowheads on the end of it. There. And there. Okay?